very much, Bertrand, for the introduction and for the invitation to this really exciting workshop. I'm a research scientist at LBNL, and I work on energy policy modeling tools, but I also work with Tianzhen Hong and his group at LBNL on occupant behavior modeling tools in buildings. And I've been involved for a few years now in the occupant behavior modeling community, which has really grown quite a bit through efforts from Liam and others in the International Energy Agency community, with the annexes, and through other kind of policy-focused efforts. And so I'd like to talk a little bit about that experience and how that might feed into the development of a human building interaction research community. So I would postulate that, based on these experiences, in the occupant behavior modeling community, there's really 4 elements to a research community that's successful. The first is an organizing concept. So why are we all here? What do we all agree is important to look at with our work? The second is policy framework. So who's going to fund that work, basically? The third, common data sets. How do we share information across disciplines? And then the fourth, how do we understand each other's methods, which may be as well very interdisciplinary. And so, starting with concepts, I certainly don't have any answers as to what the organizing concept of this community will be, but I'd ask that we think about 2 things here in developing a concept for HBI, or human building interaction. The first is that we all have certain biases about what a building is. And that includes those of us that don't necessarily work with building design or simulation every day, because obviously we all live and work in buildings and have our kind of preconceived notions of what those buildings look like and what our experience is with them. And so I think it's instructive actually to go back to one of my heroes from architecture school, Peter Rainer Banham, who is an architectural historian and critic, a British critic. And what Banham was really good at doing was to kind of take a step back and look at some of the technological developments of his time and how they might influence what we understand as architectural form and architectural elements. And so here in this article, A Home is Not a House, he's sitting in this environmental bubble with his friend Francois Dallegret, and they're sitting around this standardized living package, which is transportable. You kind of create this environment wherever you are in the world. And so what that is essentially asking us is, can we shed our conventional notion of the architectural form based on this explosion in kind of mechanical services and the capabilities around providing those services for basic occupant needs. So similarly, I think now what we can do is extend this to digital services in buildings. And how does architectural form then change once we start to talk about generating that form based off of digital services and capabilities? And then secondly, I think it's important to recognize that in the occupant behavior world, over the last several years, our focus has really been on prediction, I think. So we were interested in, especially how do occupants influence energy use in buildings? And this is obviously very important, certainly a really interesting policy question. We've looked in previous annexes at occupants as one of 6 influencing factors in energy use. So they're kind of part of that mix. But I think for the development of this field, the real opportunity here is in not considering occupants as kind of just as kind of a useful element of prediction, but also trying to explain occupants and how they interact with space and buildings. Right? So can we focus on the individual building occupant and create a science of spatial perception and adaptation around that individual occupant? And the interesting thing there is that once you do that, you can then aggregate up the information that you've collected about how people interact with space and buildings into these very good predictions about other things that people care about, energy use, productivity, comfort, etc. And I would argue you'd be able to do that then in a much more generalizable way. So 2 things related to organizing concepts. So now moving on to policy frameworks. So I work a lot with the DOE Building Technologies Office in Washington, D.C. And one of the things that I've tried to do quite a bit over the last few years is to create some space for occupant-focused technologies within the DOE portfolio. And I think the best home we found so far is in this area of occupant-centric controls, which lives within the sensors and controls sub-program within DOE. And occupant-centric controls are now positioned as kind of one of 4 major areas that sensors and controls, the program is interested in pursuing, which I think is a great achievement because it positions occupants as a technology or a system, if you will, alongside all these other technologies and systems that DOE is conventionally considered funding. And so over on the right-hand side here, just some results from some analysis that I did using a tool called Scout, which is a national scale impact modeling tool. So we can feed in all these technologies and approaches and look at the impacts of those technologies and approaches in the building sector on energy, CO2 emissions, and operating costs. And so this really brings occupant-centric controls into the mix as a technology that then can relate to energy, national energy and climate goals. And that's important from a policy perspective in creating something quantitative, creating something that you can track and put some R&D numbers behind. So actually one thing I'd really like to stress is that there is what's known as a request for information out on a roadmap around this program. And unfortunately, responses to that are due Monday. But if, they can actually be very brief, though. And I think one of the problems with these RFIs is that they go out and only the people who've worked with DOE in the past respond to them. And so when you start to look to new technology areas, you don't get a lot of responses, and then DOE just thinks that there's nothing there. So with all these great people in the room, if there's one thing you could take away from this, is just go on the ERE Exchange, search controls, and find this request for information, and just talk a little bit about your work and how it might relate to DOE's interests, because there's literally millions of dollars behind those responses, so they're really worth just a few minutes of your time. So occupant-centric controls extends outside of DOE, and one of the things that I worked on with Tianzhen is establishing groups within industry, so in this case within ASHRAE, that are focused on occupant modeling and occupant-centric controls. And so we have this, what's known as an MTG in ASHRAE, that's kind of a collection of researchers that focuses on occupant behavior. And one of the real successes, I think, recently is we have gotten a chapter on occupant-centric controls, sensing and controls, into the ASHRAE applications handbook. Now that is, to give you some context, one of about a gazillion chapters in that handbook, but it's actually very important because it creates a home for a lot of the research around occupant modeling and now, I think, human building interactions. And ASHRAE is of course very influential for those of you who don't know it in the building technology industry. Then moving on to data sets. So one of the things that I've contributed to recently is another ASHRAE-funded project. It's known as the Database 2, and this is in the area of thermal comfort. And so some of you may be familiar with an effort called the RPA84 database, which was produced in the late 1990s, I think, and informed a new thermal comfort standard for ASHRAE. This is the successor to that project. And it's really a powerful database in that it involves, I think it includes 76,000 complete sets of thermal comfort data from around the world. Some of them are longitudinal data, some of them are cross-sectional. So it's a really rich data set that you can do a lot with, both in the occupant behavior modeling community and now I think in the HBI community. And there's also a nice shiny web app attached to this that's the Center for the Built Environment at Berkeley led the development of, and of course you can download all the data for your own work, most importantly. There are also some proposed things around data going on now that I think will be relevant to this community. So again, starting with ASHRAE, Tianzhen and I, along with a few others, are working on getting funding for a global occupant database that's ultimately inspired by the ASHRAE RP84 and comfort database I just mentioned. It seeks to bring together an international community around providing data on occupants of all formats and buildings, but then also curating that data and making sure that everybody can kind of understand at a meta level what's going on with the data sets. So we only have 10 contributors so far, and I would be very interested in having any contributions from this community, so please email me if you're interested in contributing to that. On the IEA project that Liam just mentioned, Annex 79, we are working on a synthetic occupant population that is meant to kind of take typical occupant characteristics, thanks Christian, preferences, etc., and initialize a set of simulated occupants for things like agent-based modeling. And then there's a Nature Scientific Data special issue that we're working on occupant behavior in buildings, which uses standard ontology to describe several different occupant behavior data sets around the world in repositories that mint DOIs and are very accessible to the rest of the research, scientific research community. So finishing up on methods here. So on the data collection side, two projects I just wanted to mention briefly here. One of the projects focuses on non-intrusive ways of detecting occupancy in buildings. And so this project uses Wi-Fi infrastructure, existing infrastructure in buildings, to infer occupant counts using machine learning. So it uses a feature engineering technique to kind of group all of these different MAC addresses into long-term inhabitant and visitor groups, as well as office appliance groups. And then, based on that data processing, applies random forest and other machine learning techniques to infer occupant counts over time with a high degree of accuracy. So that's important because it's low cost and it's non-intrusive, so we can collect lots more data that way on occupancy. The second project is a project that we're contributing to with LSU. So Yiming Zhu is leading this project. It's an NSF funded project. Really interesting in that it's looking at differences between occupant perceptions of the thermal environment in situ setups versus setups where we're actually creating that environment in an immersive virtual reality using a immersive IVE device. And so what we're looking at there is whether the responses to the thermal environment significantly differ across those two things, which is important because IVE obviously offers a lot of opportunities in terms of how you might create new longitudinal data sets on a shorter time frame and with fewer resources. And then finally, on the modeling side, what we've done at LBNL, and specifically Tianzhen has done, is create these new ontologies to describe occupant behavior data and occupant behavior models in a way that can be exchanged easily with building energy simulation and other programs using standardized interfaces like the functional mockup unit interface, which kind of describes a standard set of functions and data ontologies that can be used to co-simulate different programs. Last thing I'll mention is just that in the occupant behavior community, we haven't really looked at agent models very much. And I think a lot of that is just because, again, the focus is on prediction. And we've come with this very useful and interesting fit-for-purpose approach to occupant modeling, where you look at the sensitivity of your output of interest to occupant behavior. And if it's not very sensitive, then you don't really need a very complex occupant behavior model. And so that often precludes things like agent models, which are quite time-intensive to develop. But I think as we start to move to the human building action interaction community, these agent models become a lot more relevant because they can be useful tools for exploring, again, why occupants are behaving in a certain way, which we haven't done as much in the existing community's work. Okay, thanks for putting up with my scrolling, but yes, do I have any time for questions?
Yeah, 1 minute actually.
1 minute, okay, great.
So you're using ontologies, and could you tell us exactly how you're using ontologies and where does it come into play in this? Because there's so many different possibilities, right?
Yes, absolutely. So in this case, what was done was there was kind of a survey done of the existing psychology literature relative to human perception and action. And on the left-hand side, this ontology called DNAS, Drivers, Needs, Actions, and Systems, was developed as kind of a practical way of synthesizing all of that work into these components that would be relevant for representing an occupant behavior models. So you have your drivers, environmental factors, needs, occupant requirements and preferences, actions, system interactions, and then the systems themselves and how you describe those. So that ontology then feeds into these co-simulation tools as a standardized way, or proposed standardized way to represent occupants. I don't think it's the final word by any means, and I think as we look more at individual level occupant modeling, we might create new ways of describing this, new ontologies, but that's just something that hasn't been as much of a focus so far.
Like introducing the behavioral component.
Yeah, right, exactly.
Thank you, Chair.
Yes, thank you.